To kick us off, I'd like to invite Professor Paul Salmon from the University of the Sunshine Coast's Centre for Human Factors and Systems Science to give the keynote address for today's forum. Paul has 25 years of applied human factors and systems science research experience. His current research interests are the application of systems science to manage societal and global level risks such as artificial intelligence. Paul has received several prestigious awards from the international, Australian, US and UK human factors and ergonomic societies, and is recognised as a leader in his field. So we are very pleased he can spare some time to speak with us today on HF and AI in a rail context. Welcome, Paul.
Thank you, Fiona. It's an honour to be here. Thank you for inviting me to come along and present. I've shared my slides, so hopefully that's worked okay. Someone do tell me if it hasn't. Thanks everybody for coming along. Really happy to give this talk today. So my presentation really is about AI safety and some of the work that we've been doing around the risks associated with AI, and specifically then I'm going to relate it to rail in particular. So I hope you enjoy it, and we'll see how we go. I've maybe got a couple of extra minutes now because we're early, so that's good because I do tend to go on a bit too much. So I'll jump straight into it. And so what I'm basically going to talk about really is I'll give a bit of background around AI, and then I'll touch quickly on, some, I guess, enduring theories and seminal works that we have in human factors around technology insertion, because I think they're really critical to how we manage AI safety across the different domains in which it's being used. I'll touch on cane toads, bear with me. You'll see what I mean when I talk to that. And then really we'll get into some of the risks associated with AI. So I'll talk about some of the findings from a research program that we've been involved in, where we've been really systematically trying to identify different risks of AI in various different contexts. I'll then shift specifically to rail and talk about rail use cases, and then really the last part is the main component where we talk about well, how can we use human factors and ergonomics to actually ensure that rail AI is safe, ethical and beneficial. The image on the slide there, for anyone who's interested, that's an AI system in India that is a wildlife detection system that basically detects when wildlife goes on the rail tracks. I'd like to bet that hasn't been trained on kangaroos, so I'd be interested to see how that works over here. So in terms of AI and the background that I wanted to touch on, so basically, we're all kind of across this as HF people. AI has now being used in almost all aspects of daily life. And I always acknowledge at the start of my AI safety presentations, look, there are many benefits associated with AI, and I could give a presentation on the benefits, but really I'm here to talk about AI safety and the risks. So I do acknowledge there are all sorts of benefits, but my focus today is risks and how we manage them. And these risks really have been discussed in various areas. And what we've seen in different sectors really is that you have various principles or guardrails or frameworks for responsible AI that have been proposed. But really what our argument is, and a lot of our work is showing, is these are not particularly great. They don't really have any kind of discernible effect on ensuring that AI is safe. And in fact, it's not actually clear to many stakeholders how we can ensure that AI is being used safely, ethically, and beneficially. And as a result of that, it's causing harm across society in various different spheres. My mouse is gone. I mean, it's always interesting to me as a human factors person and talk to a human factors crowd, because we're well aware that disruptive and unruly technologies are not a new problem, and in fact it's probably the foundation on which our discipline is based, coming through the Second World War. And so we do have seminal works, theories, models and methods that can be used to deal with this problem. And part of an issue there is they're not really being translated in the area of AI safety. So the first kind of work design approach we have is socio-technical systems theory. I stole this slide off Gemma Reed from a PhD, I think. So this was developed in the Tavistock Institute in the 1950s, and it was really a response to an increased use of advanced technology in workplaces, where they were introducing new technologies and finding lots of interesting emergent properties. So yes, work may have been getting done quicker, but they were finding lots of interesting things like, people were enjoying the work less, there was increased absenteeism, there was new injuries and new forms of kind of incidents. So they were kind of really interested, well, how are we supposed to optimize the insertion of new technologies in work systems? And the theory talks about things like participatory design, humanistic values, this idea of meaningful work. And it talks a lot about how organizations are open systems that are in fact affected by their environment and must be able to respond to that, to changes in context and disturbances. And so there's a focus on adaptive capacity, which is achieved through joint optimization of human and technical components. And another slide I stole off Gemma, sorry Gemma. There is a number of values and principles for how you design work systems around that. And I won't go through it all because you can see it's quite a complex diagram, but I will point to those socio-technical systems theory values around the outside of that diagram. So we have humans as assets, technology as a tool to assist humans, promotion of quality of life, respect for individual differences, and responsibility to all stakeholders. And what I'll ask you to do is think about those values in relation to AI and how AI is being introduced and is being used in different systems. So my point really is STS has a lot to offer in terms of how we both design, implement, and use AI in complex systems such as rail. The second bit of work I wanted to touch on is the ironies of automation from Lisanne Bainbridge. Again, everybody in the audience is probably familiar with this, but even as far back as 1983, Bainbridge was talking about these things that emerge when you introduce really advanced technology, advanced automation into systems. And she talked about how the more advanced the automation is, the more critical the humans actually become in your system. So you can't just think that you are going to be replacing humans by introducing the technology, because actually the system becomes more complex, more opaque, and you need more reliance on humans to manage the system. She talks about how the best automated systems require the greatest investment in training. Peter Hancock's kind of built on some of Bainbridge's arguments to talk about how humans are magnificently disqualified for monitoring. So a lot of when you insert AI, it becomes humans become monitors in the system. We're actually very poor at that, and we've seen a number of incidents that arise from that. Of course, you get skill degradation because we're not performing the activities that we were trained for as much as we used to. We have less situational awareness of what's actually going on in the system, and our work actually becomes less meaningful, and we have issues like technological unemployment. So we've been talking about these issues associated with introducing advanced technologies for many years. The problem is, within human factors, we've had trouble conveying this message to organizations. So when we think of a whole other discipline like artificial intelligence, it becomes really hard for them to understand and take on these kind of key principles. I wanted to touch on cane toads for a second, because I think the big problem with AI that we're seeing is, and we talk a lot about this in the research centre here at UniSC, we're seeing the problems that occur when we introduce something into a very complex system and we only know one key property of the thing we're introducing, and we don't try and understand how that thing is going to interact with everything else in the system, and we get lots of undesirable emergent properties. And cane toads are a really perfect example of this. So I guess they could be nature's technology if you want for the presentation. So I mean, the history of it is there was a plant pathologist, Arthur Bell, who went to a conference, I think it was in Puerto Rico in 1932, and he saw at the conference the story of success around the American toad and how that had been used to control cane beetles. About 3 years later, they got a sample of cane toads from somewhere in Hawaii, I think, and they introduced them in canes. And the idea was that they were introduced to control destructive cane beetles that were destroying Queensland's sugarcane crops. And of course, they're extremely toxic through all stages of their life cycle. So the predators of cane toads were basically unable to control their population. And actually, the cane toads thrived, and they had no impact at all on the cane beetles. And they had basically a devastating impact on the ecosystem, killing lots of species and things like that. And so you can see how we had this idea that the cane toad could do this one thing very well, and it was a thing that we needed in the very complex ecosystem. We didn't really do any testing, and we didn't really think about some of those knock-on emergent properties. We introduced it, it didn't have the desired effect, and actually we've lost control. And to me, that is what is going on with AI. So we're really kind of excited about a tool that we think can do some things really well. So we're introducing it to do that, but we're not really considering, well, what happens when it interacts with something else in the system, or how will it respond in this edge case, or how will it happen here? So I just wanted to touch on that because to me, it's a classic case of not understanding the potential for undesirable emergent properties. So let's talk about what some of those emergent properties actually are. And so I'll talk through some of the issues with AI, and because this is, quite some serious issues, I always start off lightheartedly and move into the more serious issues. And so the first one that I like to talk about is the Willy Wonka experience, which was a show which was set up in 2024 in Glasgow, where some group wanted to kind of cash in, and they put on a Willy Wonka show, and they used AI extensively both in the marketing and promotional material, and they also wrote the script for the show with AI, allegedly. And so what you had was, you had the advert at the top of the slide there, you had reality at the bottom of the slide, so it kind of looked like this. The story was really quite weird. Instead of Willy Wonka, you had Willy McDuff. Instead of the Oompa Loompas, you had Wonky Doodles, and this guy here is the Unknown, which was an evil chocolate maker who lives in the wall. So you had kids at the experience kind of going, "What? This has got no bearing to Willy Wonka and the Chocolate Factory whatsoever." And the obvious pile on from social media happened, and it became terrible, and I think the police were called, and everybody needed to get their money back. And so the use of AI here was kind of three-pronged, in that the marketing and the writing and the advertising kind of gave this a false sense of what was going to happen, and also gave a ridiculous story that had no kind of resemblance to the original story. A more kind of one closer to my interest around sports. So this is a basketball player called Klay Thompson. So when you're playing poorly in basketball, you often get it described as you're throwing bricks. So he was playing poorly one night, I think it was for San Francisco at the time. It went round Twitter that he was throwing bricks. Somebody cracked a joke, and the Grok AI system actually kind of misread this and said that this guy had gone on a vandalizing spree around a local neighborhood throwing bricks through windows. So totally misunderstood the context, and then actually spread misinformation about what was actually going on. And Rail is not immune to this. So this was something that happened in the UK. So an earthquake, or tremor, if you like, happened across Lancashire and the Southern Lake District. A kind of doctored AI generated image was sent around on social media, and Network Rail had to basically step in and stop the train services while they went and sent a team to investigate the bridge and what was happening. And so, the image is being created with AI, and it's being sent around, and misinformation ensues. So there's just some kind of, interesting examples there. But of course, we know that there are far more serious examples. So some of the examples I have on the slide are some of the different things that occur when you introduce AI into socio-technical systems without really applying a human factors kind of approach to support that. And so we know that it makes systems more complex, brittle, and prone to failure. So you have the Boeing 737 MAX system, which resulted in 2 large-scale loss of life aviation crashes. We are seeing increasingly how it's potentially removing meaningful, rewarding, and healthy work across sectors. So, it's currently happening in manufacturing, customer service, coding, media, content, retail. There will be more sectors that will suffer from that. It introduces what we call unruly emergent behaviors, so unexpected behaviors that can actually be harmful. And a good example of that is chatbot-related suicide and self-harm. There's a few cases against people like Anthropic at the moment around that. Issues of skill degradation and situational awareness, so where the AI and the humans aren't working well together, and so the human loses situation awareness and something bad happens. The Uber-Volvo collision is a good example there. We have all sorts of risks around biases, inequality, discrimination, and ethics. A good example is the Amazon recruitment tool that was developed, and it was trained on male CVs only, so therefore would only offer males an interview for the job and rejected all female applications. Creates an opportunity for malicious use. We have things like deepfakes, election manipulation, and cyber attacks. Deepfakes, for example, I read a recent report from there was a report from UNICEF that basically described a study where they'd asked a bunch of children across 11 countries about deepfakes, and I think they found that 1.2 million children disclosed of having their images manipulated into sexually explicit content. And in some cases, in some of the countries, that basically equated to one child in every classroom has been a victim of a deepfake. And then a really interesting set of risks, which I'll talk about in a bit more detail later, is the new risks that occur where the broader socio-technical system is not ready for AI. And a good example of that is large language models such as ChatGPT, when they were introduced into higher education, and all of the kind of scramble that university sector got in around how are we going to manage this, and that's still actually going on now. So lots of different and interesting risks. And so we've been, obviously, as HF people in the centre, we've been really interested in this, and we've been kind of engaged in a program of AI safety research for probably 4 or 5 years now. And I've got various projects on the slide there, but effectively we're applying human factors methods to identify the risks associated with AI in different systems. We've been developing life cycle support frameworks to actually, show stakeholders where human factors methods can be introduced to actually help manage some of the risks of AI. We've been looking at stakeholder perceptions of AI use, and more recently we're looking at human AI teamings, and it's funded through various areas. So what I'm going to do is talk basically about that program and basically bring together the findings and talk about what that means, I think, for real. So this slide is as technical as I will get. So one of the projects we had was basically applying systems HFE methods to forecast the risks associated with advanced AI in different systems, and we did this in road transport and defence. And just to take you through how we kind of identified these risks. So we use the event analysis of systemic teamwork broken links approach. So what you do here is you build a task network of all the tasks in a system. You build a social network showing all of the agents and actors in a system and how they interact together, and then an information network showing all of the information that you use. And what you do to this to identify risks is basically you assess what risks emerge if information isn't passed between the tasks in the task network and between social agents in the social network. So we kind of do this really comprehensive risk assessment. We've also used work domain analysis and what's known as the broken nodes approach. And here what we're doing is building models of the socio-technical system in which the AI is deployed. And we're basically saying, well, what risks emerge if different functions in that work domain analysis are performed poorly, or if they're performed really well by a super intelligent AI? Are there also any knock-on risks from that side? So again, very structured, comprehensive risk assessment approach. And the final approach that we've been using quite extensively is STAMP and STAMP STPA. And here what we do is build a control structure. So what you see on the slide on the bottom right hand side there is a system hierarchy with different levels and different actors and organizations, and you have control mechanisms that are enacted down to manage risk, and then feedback mechanisms that flow back up the hierarchy to provide information around how the system's performing. And with this one, we basically say, well, what are the risks that emerge if either the control mechanisms don't work, or they are used wrongly, or they're inappropriate, and also the same for the feedback mechanism. So we've applied this kind of, we call it a many model approach. And the key point is it's extremely comprehensive. So in cases here, we were identifying, thousands of risks and basically then pooling them together into different categories. So I just want to run you through some of the risks that we found, and some of these are not so relevant because they're to do with really super intelligent future AI, but I think many of them are very relevant, and we'll come back and touch on those. So if we start at the top, we have suboptimal performance risks. So these are just very straightforward risks where the AI just isn't very good at doing what it's supposed to do. And what you have as a result of that is adverse events, basically. So, the Uber-Volvo collision is a good example there of where you had AI that wasn't great, and there was a collision because of it. Alignment risks and super intelligent risks I won't talk about today because they're for very kind of future systems. I think we'll talk more about contemporary risks. Enfeeblement risks is a really key one, I think. So this is about where we start to insert AI into systems and we become really reliant on the AI, and because of that, the humans are doing less of what they would normally do in the system. And so here you have risks around technological employment, so you're getting rid of humans and replacing them with AI, skill degradation in the humans because they're doing less of the work that they're supposed to be doing. Interestingly, there's some interesting risks about an over-reliance on AI, where we become too over-reliant, and then when it does start to fail, we can't then extract it from the system because the system has become too reliant on it. And then also a loss of meaningful work for humans and what all of the kind of knock-on effects that has. At the bottom there, we've got over-controlled risk, which is basically where our controls are so tight that we actually can't get any benefit of AI because we won't let it do what it's very good at doing. So that was another interesting set. Malicious use risks obviously is a big set of risks, and particularly where you have systems where there's lots of data, which I think Rail is one of those systems. So you have issues around privacy and security, you have cyber attacks, misinformation and weapons development. Organizational risks are when the organizations deploying AI just aren't ready and they don't have the processes and procedures and systems in place. And here we get all sorts of issues around the humans not working very well with the AI simply because they haven't been trained to do so very well. The procedures aren't clear. There's a lack of monitoring, a lack of incident reporting, and so on. And then at the top left, we have socio-technical systems risk. So this is more in the broader socio-technical system where you have things like governance failure, environmental harm through development of the AI, biases and inequalities, unethical AI, welfare and rights issues, and also power centralization, where some people have access to, some organizations or groups have access to the AI and others don't. So that's lots of thousands of risks grouped up into certain categories. What I wanted to do now is basically switch to Rail and talk about, how do they kind of fit to Rail? How do they align with Rail? Which ones should we be more concerned with? Which ones are we not so concerned with? And so I wanted to touch on, how AI is being used in Rail currently. And these are the kinds of the images you get if you search for this, by the way. You get, these glossy images of, an advanced train with lots of signs popping up all over the diagram, which are telling us that AI is doing something interesting. If you look in a bit more detail, there are some very clear use cases of AI in Rail that are becoming quite mature. There are some that are less mature, but some that are mature. So predictive maintenance is one where I guess across the world AI has been used quite extensively, and also fault detection, things like tracks and things like that. Obviously, we have autonomous and semi-autonomous trains where we're using AI to either drive the trains or provide driver assistance. Dynamic scheduling and traffic management. Energy optimization, infrastructure planning and network resilience, safety and security, enhancing the customer experience, and also crowd and flow management is quite a mature use case, and also data systems. So I was reading about one interesting system, which is an AI-based instant reporting analysis system, which is really interesting. So you're seeing it being used really across the entire Rail system. It's not just about driverless trains. Effectively, it's being used for various different functions in the Rail system. And so, a good report to look at would be this one, the International Union of Railways on AI-enabled railway companies, which is a report that was written in 2024 about where this could all go. And the McKinsey and Company wrote an interesting report where they did a kind of consultation, and they looked at where's AI being used and where do people think it could be used? And they came up with 4 groups: so railway undertakings, infrastructure management, passenger experience, and support functions. And the dotted line, the blue with the dotted lines, are the ones that were kind of being used when they were being interviewed, whereas the non-dotted lines are things that people saw potential for. And so you can see a lot of what I've just discussed around network planning and optimization, network maintenance, customer railway journey and passenger information about enhancing the passenger experience, operations and crew scheduling and planning, train station related operations, and so on and so forth. So it's quite being used in quite different areas. As I said, those are at different levels of maturity. So this is a kind of maturity graph about those different use cases, and you can see things like crew and shift optimization, predictive maintenance tech tools. They're really I think they call it the new digital normal. So they're being used extensively, whereas things like having digital twins of network infrastructure, real-time recommendations around disruptions, they're just being tried in very few places, and they're really quite new. So it's being used quite extensively. So if we take those use cases and we go back to the kind of risks that we talked about, there are some groups that I see are really more relevant than others on here. So obviously the first one, suboptimal performance risk, where the AI isn't well designed, and so because of that, there are adverse events that can happen. I mean, this is a clear one for things like fault detection systems. So, a fault detection system that doesn't work very well and misses a particular fault on the line, and obviously driverless trains or autonomous trains that experiences a non-routine scenario that hasn't been trained for, and so you have a crash that results of that. The next group is enfeeblement risk. So I think this is a very clear one. If we think of all of those different use cases, you can see that there's obviously a risk for technological unemployment where we're replacing human workers, skill degradation, and again, I think a fixation on trained drivers isn't very helpful there. It's skill degradation more across real systems in other roles, I think, is more important there. Over-reliance on AI for sure, and also a loss of meaningful work. Over-controlled risks is probably relevant, but less so based on that report. The malicious use risk is really interesting. Like, I think because a lot of those systems are about data and about monitoring and about, even surveillance around passengers and passenger flow, I think this is a really big risk area. So you have things like cyber attacks, you have the privacy and security issues around those. I think they're going to be something that's really worth looking at. And then the other two obviously are very relevant. So, I have real organizations who need to be ready for the technologies they're deploying, and then also the broader kind of rail system and the governance around that. So there's a bunch of really relevant risks, I think, based on the risks we've identified for our work in this area. So the question then is, well, how are we going to use human factors to actually develop safe, ethical, and beneficial rail AI? So I'll talk you through some of the things we've been doing in our programs that I think are really relevant. So I'll first talk about some of the classic fails that we're seeing in AI risk management. So across the different sectors we're working in, what are people doing wrong or missing that's actually resulting in, adverse events or, some of those risks that we talked about? So I think the first one that I'll touch on the next slide in a bit more depth is really a failure to consider AI risk as a systems phenomenon. We're still very much too focused on the AI technology itself and the things that can go wrong with that, rather than how it can create emergent properties in the broader socio-technical rail system. So I think that's a key part, and it links very clearly to the second one, which is we are obsessed with tool-based risk assessment. So the risk assessments that I talked about were very much about modeling the socio-technical system first, inserting AI into the system, and then basically identifying what risks can emerge from that. What I'm seeing too much across sectors is people are just taking AI tools and trying to work out what risks the AI tool can create on its own, when that's really a very narrow view of risk and of AI safety and of socio-technical systems. Some more straightforward ones, what we see with organizations who in some cases are knowingly deploying AI, but most cases deploying AI, knowingly deploying AI, a real lack of education, training and awareness for its staff around the responsible use of AI. So, when they do unleash these technologies, quite often there isn't any kind of awareness activities, there isn't very formal training around that, they don't have education. So people are left wondering, well, how should I be using this? When can I use it? When can't I use it? When is it risky? When isn't it? Also see a failure to acknowledge worker fears around AI and impact on their roles. This is a very real thing, that's influencing behavior in any system in which AI is being deployed. And we rarely see organizations tackle this and seek consultation around these fears and then actually engage in the work to alleviate these fears and actually work through them. So that's a problem. A lack of oversight of AI use beyond stipulated tools. This is a really interesting one, particularly in the university sector, where an organization may mandate a set of AI tools that can be used, and they might assess how those are being used, but they're not assessing how all of the other AI tools that we can freely access are being used in our work. And that's a really interesting blind spot, I guess, for risk and risk management that we see. A real big gripe of mine is responsible AI use principles. So you'll see these, there's probably some in rail. I think I remember seeing some in the UK, where there's a very high level set of responsible AI use principles that really don't tell us anything about how to use AI responsibly. And actually, often it's impossible to adhere to them. So a good example is something where it would say, we need to use AI tools sustainably and ethically, or we need to use ethical and sustainable AI tools. None of the frontier models that have been developed ethically or sustainably. So if we're allowing use of those tools, then we can't adhere to that principle. So I think there's a bit of clearer thought around responsible AI use principles, but also the detail around them and how we can actually adhere to them. And I'll talk a little bit about that in a second, of how human factors can help there. And then a really interesting one that I see everywhere is a lack of feedback mechanism. So when we think about that stamp control structure, what I see is organizations are introducing AI, but they're not monitoring how it's then used. They're not updating their incident reporting systems to build in contributory factors based on AI tools. So they're really not learning about emergent risks, emergent properties, and how AI might be causing problems in their systems. They're just kind of deploying it and staying with their current monitoring systems, which is a big issue. So what do we do about all this then? I've got one eye on the time. I've got 10 minutes, I think, so that's good. So the first thing, as I said, is we need to acknowledge that AI safety is a systems problem. It's a socio-technical systems problem. Therefore, we need to use systems theory, systems HFE methods and models. And anyone who's seen me talk, I talk a lot about Rasmussen's risk management framework, which is a very simple framework. And we kind of adapted that to align to our AI safety work. And so there's 5 key principles on the slide here. And so we have to acknowledge that AI technologies are one component of a complex dynamic system that comprises multiple interacting components. And that are human components, that are non-human components. Some of the other components may be AI, etc., etc. So you have this really complex interaction. Because of that, number 2, there's a shared responsibility for AI safety that spans all actors and organizations residing within that system, everybody on that hierarchy on the left of the slide there. What I see is a really interesting debate around responsibility and accountability for AI, where there's really a surprising amount of people who think the responsibility for what AI does is allocated to the last person who interacts with the AI, when we have a whole network of stakeholders across that hierarchy who actually share the responsibility. And that includes the organizations deploying AI, the governance agencies who are governing AI safety, and of course the developers who are developing AI tools. So we have to start to think from a shared responsibility perspective. AI safety and risks are emergent properties that arise from interactions across system components, not just the AI technology and its end users. Yes, we need to understand how the technology and the end user interact and how that behaves at the sharp end, but we also have to understand all of those other different interactions across the system that shape that sharp end interaction, just as we do in any systems HFE work. Any adverse event involving AI is caused by multiple contributory factors across the system, so we need to understand those. And really what we need to manage AI safety is a control structure that has a network of safety controls and feedback mechanisms spanning all levels of that socio-technical system. So we can't just rely on things like training and education for the end user of AI at the sharp end or the bottom of that hierarchy. We have to have a system of controls across the entire hierarchy. A paper I was asked to write in the Journal of Transportation and Planning Technology, relating that specifically to human factors and ergonomics. I basically talked about what factors should we focus on as HFI people when we're trying to optimize AI and AI safety. And I grouped them into 4 there. So I see AI factors. So, things like the data that the AI is trained on, we need to think about any potential biases, transparency and explainability in the AI, ethics. You then have to think about the human interaction, so that sharp end interaction, the human machine interface, usability of the AI, Distributed situation awareness, how that works, is the human aware of what the AI is aware of? Is the AI aware of what the human is aware of? Workload, trust, human AI teaming, all those really, interesting human factors concepts. But really 3 and 4 for me are the most critical. So 1 and 2 we kind of do, day to day as human factors people, but 3 and 4 is what's being missed. So organizational factors, things like changing the job and work design when we introduce AI. I see too many organizations inserting AI and not actually having a good hard look at the procedures and saying, well, does it fit within the current process? Do we need to redesign things? How does it impact different tasks? Risk assessment and management. Are we conducting effective risk assessments before we're introducing AI? Does our training program incorporate AI use? Do our policy and procedures? Do we have an incident reporting and learning system that can track AI use? Most cases they don't. Socio-technical systems factors, and this is the broader stuff, often can be viewed as out of some people's control. So governance, standards, legislation, regulation, design guidelines, and so on and so forth. Basically, we need to do all 4 if we're going to make sure AI is effective and make sure that it's safe, ethical, and beneficial. So specifically how human factors can help there. So this is some work that we've done with Trusted Autonomous Systems and the Defense Science Technology Group. This was about an AI-based target decision support system. And what they were interested in here is looking at those responsible AI use principles and saying, which human factors methods can be used to tell you whether you are adhering to those responsible AI use principles, and also where in a design, in a technology life cycle, do we need to use those human factors methods. So what you have on the slide there is a framework that we developed around human factors methods. So we basically reviewed a whole bunch of methods and we said, well, where can these be used to support the design of safe, ethical and usable AI in this defense context? So the green boxes are basically a standard life cycle. It probably has different terms in real, but it's basically, strategy, you're identifying the need for something, you're doing some risk assessment, you're acquiring or designing a technology, you're implementing it, and then you're having some kind of decommissioning at the end. The boxes are the activities we kind of were suggested needs to be done throughout the life cycle to ensure safe, ethical, and usable AI. And you have the human factors methods alongside each of the boxes where we're recommending different kinds of human factors methods that should be used. The shading I won't talk too much about. That's just where we think you can look and tell whether a particular technology is adhering to a responsible AI use principle or not. So I won't really touch on that, but effectively some examples here. So where we're not seeing this kind of work done. So in the second box there, risk mitigation and requirements setting. So once there's been an identification of a capability need, for example, and you're kind of thinking, well, right, we're going to introduce an AI technology to fulfill this capability. What we're recommending after that is that there's some sort of assessment of the socio-technical system in which the AI will be used. So we're not talking there about doing any assessment of the AI technology itself. We're basically saying there needs to be a model of the socio-technical system. So in this case, the rail system. Methods that you could do that with are on the slide there: work domain analysis, STAMP, HDA, East cause loop diagram. A good example there is you could build a STAMP control structure of the rail system, and you could identify what controls and feedback mechanisms you currently have in place around safety. What you then do, the second box in that second green box, is you then use that model to do some prospective risk assessment. So you actually say, well, we have this technology that we're thinking about, this AI technology. Let's say it's a predictive maintenance technology in rail. What risks can emerge within the socio-technical system once we insert it? And again, you might use something like STAMP STPA or net harms there. And so the idea is that you're really assessing risks very early on in the process, and you're thinking about controls that you need before you're actually implementing the AI. And one of the big problems that we're seeing with AI is that, controls are only thought about once the AI has been inserted in the system and is causing havoc and causing harm everywhere. And ChatGPT is a great example of that. There are different approaches also listed for if you're designing the technology or if you're acquiring the technology: test and evaluation, experimentation, operational evaluation, and incident investigation analysis. But I won't dwell on that. The slides will be available so you can have a look at that yourself. But essentially, the key message from this project was that really there's a number of activities that need to be done throughout a life cycle to ensure that AI is safe, ethical, and usable. And there's actually a broad set of human factors methods that can be used to undertake those activities. So it's very clearly showing the need for HFE across the life cycle for safe, ethical, and usable AI. I want to talk quickly, I've got a couple more minutes, on controls. So we think there are 4 groups of controls specifically. So that's controls on developers, controls built into the AI itself, controls on the users of AI, and then controls built into the broader socio-technical system in which the AI will operate. I'm banging home the message here, but the group that we see is most often done badly is the 4th group there. So the controls in the broader socio-technical system. So we kind of develop recommendations in our project around what those controls need to be. I won't go through them. You can see them in the slides afterwards, but you can see there's a big broad set. The key thing that we found in kind of stress testing this was really that to really ensure that AI is safe, ethical, and usable, you need all of them. You can't just do a few of them and think that you've got away with it. There has to be a full network of these controls. So key take-home messages, last couple of minutes. I think from an STS point of view, we have to remember that technology should always be viewed as a tool to support humans, not replace them. I think we're losing that value with AI and we need to bring it back. We should always seek to jointly optimize in all cases, jointly optimize the human and the technology. We need to ensure that the AI is fit for purpose, including for non-routine scenarios. We need to ensure that the broader organizational socio-technical system is ready. And really what I mean there is we need to ensure that there's a well-established and developed network of control and feedback mechanisms in place before implementation, not afterwards, which is a key issue. Seek to understand emergent risks and unwanted behaviors. Don't think just about the AI, think more about the broader system. And really when you're considering the use of AI, always have that thing at the back of your mind about does the human work remain meaningful? Can it still be safe, and is it still doable the way we want it to be done? And I think if you're kind of violating any of that, it's telling you clearly there's an issue. Just a quick summary, AI is everywhere. The interesting part of it is it's rapidly advancing. There are many risks that we've found in our work, and really effective management requires a multi-stakeholder approach across the entire rail system. As I said, the critical issues are likely to arise when organizations and the broader rail system aren't ready. There's an urgent challenge to get HFE and STS early into life cycles and really think about that network of controls. Last 30 seconds, I often talk about artificial general intelligence and future AI systems that will wipe out humanity. So I don't have time for that today, but I did have a look around the internet for any images of AGI-based trains that will take over humanity. I got a few of them. So I had this one. With its kind of bots that were bringing in to wipe out the humans. But my favorite was definitely this one, kind of steampunk AI-based rail train. So I thought I'd just leave you on those images, and I'll hand back to you there, Fiona. Thank you.
Thank you very much for those frightening images, Paul, and you're bang on time, so extra points for that. I'm going to just throw one really quick question at you, which we got in our Q&A. In your view, who should lead the regulation and assurance of AI use in railways? Is this a regulatory function? Is it a state or federal government function, or is it a shared responsibility across all of these?
Yeah, I think it's definitely a shared responsibility. I think you do need federal government oversight around it, but you also need a regulatory function as well within the rail system also. So definitely shared responsibility.
Yep. So it's the onus is on us as an industry to be educated on it, I would suggest, as part of that.
Absolutely.
Yep. Thank you so much. Really appreciate that. That was an excellent presentation.